Welcome everyone. Today we're going to build your ultimate database toolkit and reverse engineer a top-tier Cambridge exam answer. Listen, if you're sitting a Cambridge Computer Science exam, whether that's syllabus 0417, 0478, 2210, or 9618, you need to treat it like you're in a high-stakes newsroom. Imagine you are under intense deadline pressure. Your editor, which is the examiner in this case, needs the facts clearly structured and with absolutely zero fluff. You have got to break down the story, the exam question, and deliver the headline, the perfect answer. Now, in the exam room, I usually see two types of students. First, there's Alex. Alex is brilliant, knows the textbook inside and out, but completely overloads every single answer with raw computer science facts and zero analysis. It's just a data dump. Then there's Sam. Sam gets stressed, rushes under the ticking clock, totally misses the command word requirements, and just leaves easy marks sitting on the table. Today, we are going to look at their flawed answers, bring out the red pen, and transform those mistakes into green check marks. We are going to make absolutely sure you don't fall into the Alex or Sam traps. Okay, let's get into this.
Here's our roadmap for this session. 1. Database building blocks. 2. Choosing data types. 3. The primary key. 4. Structured query language. And 5. Exam answer breakdown. Let's move right along.
Section 1. Database building blocks. Let's dive into our first toolkit essential, understanding what actually makes up a single table database. This is the absolute foundation, guys. If you don't understand the structure of the data you're looking at, you cannot query it, and you certainly can't answer a 6-mark question about it. Think of this as laying the concrete for a skyscraper. So, the golden rule right here. A single table database is fundamentally made up of records, which are the horizontal rows, and fields, which are the vertical columns. I know, it sounds super basic, right? But under exam pressure, students like Sam mix these up all the time. When you look at a table, a database is essentially a structured collection of data allowing people to extract information to meet their exact needs. Imagine a simple store inventory. You've got a description, a price, maybe a picture. If you're asked to define a database structure in the exam, do not write a massive paragraph like Alex would. Deliver the headline. Records are rows, fields are columns. Boom, it is that simple, and it has to be that precise. Now, the really crucial point to remember here is that while you can add or delete rows as new items come in, every single item must contain the exact same number of columns. The number of records? Yeah, that will vary wildly depending on how much data you actually have. But the number of fields is absolutely fixed. Each record consists of several fields, and every single row has to conform to that overarching structure. This is exactly how data is validated when it's input into a system. It creates consistency, and consistency is the whole reason a computer can search through millions of records in mere milliseconds. Lock this rule in your brain because it's going to be the absolute secret to solving our exam question later on.
Section 2. Choosing data types. Moving on to our next tool, we have to tell the database exactly what kind of information is sitting inside each of those fields.
You cannot just throw random data into a column. You have to declare its precise nature. Before we continue, subscribe to our YouTube channel Ace the Exams at Ace the Exams IGSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so what's really interesting about data types is the sheer precision the examiner requires. A data type classifies how data is stored, displayed, and importantly, the operations you can perform on it. Look at the options we have. Text or alphanumeric handles a string of characters. Character is just a single letter or symbol, like a Y or an N. Boolean is strictly one of two values. Think true or false, 1 or 0. Then we have numbers. An integer is a whole number, fixed with 0 decimal places. Real is a decimal number. And finally, you've got date and time. Here is exactly where the Peel framework, point, evidence, explanation, link, saves your grade. If an exam asks you to identify a data type for a price, your point is real. Your evidence is that currency requires decimal places. Your explanation is that an integer would just round off the cents, making the data totally inaccurate. And your link is that using real ensures accurate financial storage. Whether it's a Boolean, a real decimal, or an integer whole number, assigning the correct data type dictates exactly how that data is treated.
Section 3. The primary key. Now we arrive at the most critical organizational tool in your entire database arsenal. This concept right here, this is what separates the top-tier candidates from the rest of the pack. To prevent total chaos, the primary key ensures we never confuse two identical people or items by giving each row a totally unique identifier. Think about it. Each record contains data about a single item, person, or event. But what happens when two people have the exact same name, or they live in the exact same house? The primary key is a field that uniquely identifies the record. It must contain data values that are never, ever repeated in the entire table. It's literally like your fingerprint or your passport number. Now, our friend Alex might write a beautifully poetic essay on what a primary key is, but totally miss the actual application for the specific question. If you don't explicitly state that the values are never repeated, you are going to lose the mark. Keep it punchy, keep it precise.
Section 4. Structured Query Language, or SQL. Let's look at how we actually ask our database questions to extract the exact information we need.
This is where we transition from simply storing data to actively commanding it. Structured query language is the standard tool for writing scripts to pull out information. These commands are the foundational building blocks of an SQL script. And remember, your queries will always begin with select. Let's break them down like a newsroom reporter getting the facts. Select is asking, what specific details do I need? It fetches the columns. From is asking, where is this story located? It identifies the table. Where is your filter? I only want the records that match this specific condition. Order by organizes the final output, sorting it alphabetically or numerically. Sum adds up all the values in a column, and count tallies up the number of rows that match your criteria. The top students don't just memorize these. They understand how they interact to form a logical, flowing sentence.
When you write a query, you just follow this chronological logic to filter massive amounts of data down to exactly what you're looking for. It is literally step 1, step 2, step 3. If I want the price of all items over $10, I select item description price from items for sale where price is greater than 10.00. It reads just like plain English if you structure it correctly. So don't panic when you see a blank box for SQL. Just follow the blueprint.
Section 5, Exam Answer Breakdown. It is time to apply this toolkit to a real sample exam scenario and see exactly where students win and lose their marks. But hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's initiate Challenge 1, Data Scan. I am putting a 60-second timer on the clock in your mind right now. Take a look at the student accommodation database called Student Room. We have 3 fields: name, block, and room number. I want you to really scan the data. What do you see? Notice the duplicate names like David Smith appearing in both Block A and Block B. Notice the shared room numbers like room 124 in Block B housing both Sue Wong and Joe Higgs. Sam looked at this exact chart for 2 seconds in the exam and just assumed the name column was entirely unique. That 10-second rush cost him the entire question. You have to interrogate the data source before you even read the question.
Now for Challenge 2. Find the flaw. The exam question asks, explain why none of the fields in the database can be used as a primary key. The low-level answer from our friend Sam lazily suggests using name, completely failing to notice that David Smith appears twice. Sam literally writes, use the name. That's it. No explanation, no evidence, nothing. While the high-level answer correctly identifies that duplicate values exist in every single column. The high-level candidate applies the Peel framework intuitively. They state their point. All fields contain duplicate values. They provide evidence straight from the table. Many students are in each block. Students share rooms, and 2 students share the exact same name. Therefore, the link is that none of them can be a unique identifier. Do you see the difference? That's how you go from a red pen disaster to a green checkmark. Let's move to Challenge 3, Speed Writing. You have 30 seconds to answer Part B. State, with a reason, a field that could be added as a primary key and give an example. Sam's low-level answer? He writes, no need for an extra field, the name is good. 0 marks. He is just compounding his previous error. Top students know that if a unique fact doesn't naturally exist in the data, you must invent a unique code, like a student ID, to serve as the primary key. A high-level answer identifies a new field, gives it a sensible name like student ID, explains that this ensures every student has a unique code with absolutely no repeats, and provides concrete sample data like ST12345. They hit every single requirement of the command word, state with a reason, and give an example. Flawless execution.
For the final part of the question, the examiner wants you to show the exact output for this specific SQL command. Let's decode it together, piece by piece. Select asterisk. That little star symbol means select all fields. Name, block, and room number. From student room, well, that's our table. Where block equals A, this is our filter. We only care about the students in block A. You literally ignore block B entirely. And finally, order by room number.
This means the final output must be sorted numerically by the room number, going from lowest to highest. You have to process these commands sequentially in your head to build your final answer.
Let's look at the results. The low-level answer loses massive marks here. Sam removed a required field entirely, formatted it terribly with random commas, and sorted alphabetically by name instead of the requested room number. He didn't even output the block column, even though the prompt specifically said select star. Whereas the high-level answer flawlessly displays the exact requested rows, formatted as a clear table, and sorted perfectly by room number, 123, 125, 129, and 129 again. Notice that when two students share room 129, they just kept the original order from the main table. This, right here, is what exam mastery looks like under pressure.
As the examiner's feedback points out, the absolute biggest trap here is simply not reading the completed table carefully enough to spot those repeats and the specific command requirements. This brings us directly to our computer science success blueprint. These are the 3 rules that guarantee top marks. Number 1, command word decoding. Did they ask you to state, explain, or show output? Answer exactly what they ask. Number 2, Peel framework application. Make your point and prove it with hard evidence from the provided data. Number 3, time management matrix. Do not rush the data scan. Spend the first 60 seconds analyzing the table before you even think about picking up your pen.
Before we wrap up, I challenge you to answer this. Based on everything we built today, what exactly is a record? Is it a single piece of data, a column, or a collection of fields about the same item? If you are paying attention to the foundation we laid in Section 1, you already know the answer. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep analyzing, keep structuring, and I will see you in the next explainer.